Hey guys, welcome to Reliterates Day 2, Part 3. In this problem, we're going to be talking about a trough. So, a trough is 10 feet long and 6 feet across the top. Its ends are isosceles triangles with an altitude of 4 feet. If water is being pumped into the trough at a rate of 9 cubic feet per second, how fast is the water level rising when the water is 2 feet deep? So let's go ahead and let's label what we do know. What do we know? We know that water is being pumped into the tank at a rate of 9 cubic feet per second. So dV/dt is 9 cubic feet per second. And we're also interested in finding how fast the water level is rising when the water level is 2 feet deep. So we can say height is 2 feet. What we need to know is dH/dt because that is the water level rising, and we want to know how fast. So we want to find the rate that it's rising. Okay, so we're given a trough, and we really don't have a volume for this trough here, but we're gonna go ahead and just categorize this volume to be the base times the height. Now, what is the base? The base, I'm going to choose the triangle to be my base. And the height would be 10. Now, in this problem, we don't have 10 changing. 10's a fixed value. It's a trough, so the trough is already fixed. So when we're pumping water into the trough will always have a length of 10 no matter what. So the water level is changing, and so is the way the water level is changing horizontally in this problem. But the height of this object is not changing ever. So I'm going to go ahead and just say that this is 10 since it's not changing. Now, what is changing when you are pouring water into the trough? Well, the water level is rising, and so is the way the water is accumulating horizontally. Okay, so we're going to go ahead and write a formula for the base, which is the area of this triangle. We're going to say that 1/2 times little b times little h is the area of the triangle. Okay, so we have v is equal to 1/2 times 10 times b times little h. Now, what we have to do, since we're not given a derivative of b, since we don't know at what rate b is changing, we have to eliminate the b variable. Well, if I look at my triangle, I have a triangle that is 6 feet horizontally and an altitude of 4 feet. So this is my base and this is my height. We have to write a relationship between these two. So here's what we're going to do. We're going to say that we're going to write a proportion of similar triangles. So this is base. My base is 6 over b and 4 over h. 6h is equal to 4b, and I want to solve this in terms of h. Actually, no, I'm sorry. I want to solve this in terms of b because I want to eliminate the b variable. So it's going to be 6 over 4 h is equal to b. Now, why do I want to solve for b? Because if I solve for b and I plug it in here, I no longer have b anymore. I have now h's. So let me go ahead and simplify this b. b can be reduced to 3/2 h. Now let me go ahead and make the substitution over here. 1/2 times 10 times 3/2 h times h. Let me clean this volume up. So we have 30 over 4 h squared, which is the same thing as 15 over 2 h squared. So this is my volume. My volume is 15 over 2 h squared. Now when I take the derivative, then all I have to do is just worry about h and h prime, or dH/dt. So taking the derivative of the volume will give me 15 over 2 times 2 h times dh dt. Simplifying this would be 15h times dh over dt. That is my dv dt. Now let's go back to the problem again. What is the problem asking for? The problem is asking for how fast the water level is rising, which is dh dt. So what am I trying to solve for? I'm trying to solve for dh dt. That means 15h has to go. So I'm going to start it over here. I'm going to go over here. In order for me to get rid of 15h, I got to divide by 15h to both sides, so that I get dv dt over 15h is equal to my dh dt. And then now I can plug in everything that I know and I'll have my answer. So it's 9 over 15 times 2, which is the same thing as 9 over 30, or you could even say it's 3 over 10 is equal to dh dt. Well, let me write that in units. Feet per second is equal to dh dt. And that is my answer. So let's go ahead and backtrack. What's going on here? Water is being pumped into this tank, into this trough. Now, when the water level is rising at exactly 2 feet, I'm going to say that's 2 feet right there. At exactly 2 feet, the water level is rising at a rate of 3 over 10 feet per second. And that's what's happening with this trough. I could even draw it over here so you guys can see a much better visual of this trough water level rising. And this concludes day 2 of related rates. And I'll see you guys in class with your notes.